Hi, let's say we have two positive charges plus q and plus 4q as shown here, separated by a distance, let's say r, shown by this dotted line, the bigger one, and we are given another charge q. We do not know the sign or the magnitude of this charge, and it needs to be placed in the same line as q and plus 4q. We know from the previous video that q needs to be negative and it needs to be placed in between plus q and plus 4q if the forces are to be in balance. I mean, if the forces on each of these charges have to cancel out, and then there has to be an equilibrium position, then the charge q has to be negative and placed in between plus q and plus 4q. But what is the magnitude? What needs to be the magnitude of q, and what is the exact position it needs to be placed between plus q and plus 4q? Now we know that the forces on q are cancelling out each other. The force exerted on the capital Q by plus q and the force exerted on capital Q by plus 4q cancelling out each other. So they need to be equal in magnitude and opposite in direction. Let's calculate the magnitude of those forces and equate them to find out where exactly q needs to be placed. Let's take this point as the origin. We know the distance between plus q and plus 4q is r. Let's say q needs to be placed at a point which is x distance away from plus q, from the origin. Now we know that the force exerted by plus q on q can be calculated by k q capital Q by x square, and that should be equal to the force exerted by plus 4q on q, which can be calculated by k 4q times capital Q by r minus x the whole square. The distance between capital Q and plus 4q is r minus x. Now this simplifies on cross multiplying to this equation, which says 3x square plus 2rx minus r square equal to 0. This can be factorized to 3x minus r times x plus r equal to 0, which gives two values of x. One is a negative one, which is outside of left side of the origin, which is ruled out. So this gives x equal to r by 3. So now this is the position at which capital Q, this charge, needs to be placed at exactly 1/3 of this whole distance from plus Q. So that is the point at which it needs to be placed approximately. And then this gives us the position. But what about the magnitude? Okay, so we know that capital Q is negative and it exerts an attractive force on plus Q, and plus 4q exerts a repelling force on plus q. So between q and plus q, q exerts an attractive force on plus q. We also know that 4q exerts a repelling force on the charge plus q. So no, these two forces are in opposite directions and they need to be equal. We can use this to find out the magnitude of q. So let's first find out the force between plus q and the capital Q. This can be found out by kqq by r by 3 square, because we know x now, so it's r by 3 square. This should be equal to k times 4q times q, which is 4q square, by r square. Once you simplify this, we'll get 9q equals 4q. So this gives us q as 4q by 9. We know that it's negative, so it's a negative 4q by 9. So the magnitude is 4q by 9. Minus 4q by 9 is the charge, and the position has to be at 1/3 of the total length from plus q, this way. Thank you.